Hello students, welcome back to your YouTube channel Mathematics for Everyone. In this video, we shall take the questions from the miscellaneous exercise of chapter 3 functions of class 11 maths. First question. The relation f is defined by the relation f is defined by fx is equal to x squared, comma 0 less than equal to x less than equal to 3, then 3x, 3 less than equal to x less than equal to 10. So first is x square, 0 less than equal to x less than equal to 3, then 3x for 3 less than equal to x less than equal to 10. The relation G is defined by the relation G is defined by Gx is equal to x square or 0 less than equal to x less than equal to 2, then 3x for 2 less than equal to x less than equal to 10. Show that f is a function and g is not a function. G is not a function. We want to prove it. So let us take a solution. We have fx x squared less than for 0 less than equal to x less than equal to 3, 3x for 3 less than equal to x less than equal to 10. Then the relation gx is x squared for 0 less than equal to x less than equal to 10, 3x for 2 less than equal to x less than equal to 10. Then this implies fx is defined for x belonging to closed interval 3 to 10. For x is equal to 3, we can use both rules. Fx is equal to x squared implies fx is equal to 3 square minus 9. Sorry, 3 square is equal to 9. And fx is equal to 3x implies f3 is equal to 3 into 3 is equal to 9. Now, here we can see that the value of F3 is unique. Why? Because 3 has the same image 3. In this relation x square, for the element 3, the image is 9. Then for the relation 3x, for 3 element, the image is 9. That means 3 has not different image. 3 is the element of domain. So if the element of domain has same image in the range, then that is a function. Therefore, the value of F3, the value of F3 is unique. Why? Because they have same image, as 3 has same image 9. As 3 has same image 9 in both cases. In both the cases. This implies f is a function. Exactly in the same way, we shall do for g. Now, we have gx is equal to this. We are doing this in the same way as we have done for fx. This implies 0 less than equal to x less than equal to 2, gx is x squared. Therefore, gx is uniquely determined for is uniquely determined for closed interval 0 to 2, 0 to 2. And 2 less than equal to x, for 2 less than equal to x less than equal to 10, gx is equal to 3x. Therefore, gx is uniquely determined for is uniquely determined for x belonging to closed interval 2 to 10. 2 to 10. Therefore, for x is equal to 2, we can use both rules. Therefore, for x is equal to, therefore gx is equal to x square. That means g2 is equal to 2 square is equal to 4. And gx is equal to 3x implies g2 is equal to 3 into 2 is equal to 6. Now here we can see that in the case of fx, in case of fx for 3 it was same, but in this case for the element 2 of domain both the values are different. That means 2 has different images in the relation gx. That means it is not unique. Therefore, the value of gx is not unique, as 2 has different images, has different images 4 and 6. That means the relation g is not a function. G is not a function. This is, as we know, this is by the definition. If any element of the domain has different images, that is not a function. Every element of the domain must have a unique image in a range. So this is the solution of first question. Then we take second question. If fx is equal to x square, then find value of fx is equal to 1.1 minus f1 over 1.1 minus 1. Solution, we have fx is equal to x squared, f 1.1 is 1.1 squared, therefore it will be 1.21. And then we find value of f1. f1 is 1 square, that is 1. So we put values in this. f1.1 minus f1 over 1.1 minus 1 is equal to this 1.21 minus 1 over 0.1. This is 0.21 over 0.1. 21 by hundreds into 10 over 1. So this is 21 over 10, that is 2.1. Then we take next question. Third question. Third question, we have find the domain of function. Find the domain of function fx is equal to x square plus 2x plus 1 over x square minus 8x plus 12. Solution, we have fx is equal to x square plus 2x plus 1 over x square minus 8x plus 12. Now, as we know, fx is defined if its denominator is non-zero. So, fx is defined for x square minus 8x plus 12 is not equal to 0. Now we solve this. X square minus 6x minus 2x plus 12 is not equal to 0. We factorize this. X into x minus 6 minus 2 into x minus 6 is not equal to 0. That means x minus 6 common into x minus 2 is not equal to 0. That means x minus 6 is not equal to 0 or x minus 2 is not equal to 0. Therefore, x is not equal to 6 or x is not equal to 2. That means domain of function is the set of real numbers excluding this 6 and 2. Therefore, domain of f is set of real numbers excluding 2, 6. Then we take fourth question. Fourth question. Find the domain and range of find the domain and range of function defined by fx is equal to square root x minus 1. Solution, we have fx is equal to square root x minus 1. Now, since now fx is defined for x minus 1 greater than equal to 0. For x minus 1 greater than equal to 0 means x greater than equal to 1. So domain of f is closed interval 1 to open interval infinity. Now to find range, let y is equal to fx is equal to square root x minus 1, squaring both sides, y square is equal to x minus 1, x is equal to y square plus 1. Now since x is greater than equal to 1, x is greater than equal to 1, so value of x is y square plus 1 is greater than equal to 1. That means y square is greater than equal to 0. Y square is greater than equal to 0 as y is equal to x minus 1 is non-negative. non-negative. Therefore, range of f is equal to closed interval 0 to open interval infinity. Then we take fifth question. Question fifth. Find the domain and range of find the domain and range of a real function defined by fx is equal to mod x minus 1. Solution: we have fx is equal to mod x minus 1. Since fx is a real number, therefore mod x minus 1 is also a real number. That means domain of f is a set of real numbers R. Since mod x minus 1 is greater than or equal to 0, because mod is always non-negative, then fx is greater than or equal to 0. Therefore, the range of f is closed interval 0 to infinity. That's all. We have taken first 5 questions of miscellaneous exercise in this video. In the next video, we shall take remaining 5 questions. So please don't forget to like, share, comment and subscribe your YouTube channel Mathematics for everyone to see more important videos. Thank you. See you in the next video.